6.5 Work. Well, we talk about work just about every day. We go to work, we work so hard, we work out like a physical activity, say exercise. We have men who work out to fix or repair stuff, and we also work hard, say to study for calculus 2. But in science, work has a specific term or specific meaning. And work done by a constant force, in fact, is equal to W, which is the force acted on an object, and the object gets displaced by a distance d. So W is the work done by the force that you apply on an object, and it gets displaced by a distance along a straight line by a distance d. And the force that you act upon it is a constant force. Let's say, all right, suppose we want to jack up a car like this man did, this guy did, and it's a 2,000-pound car, and you want to lift it up by a 1.25 feet to change a tire, and so the jack applies a constant vertical force of about 1,000 pounds in lifting the side of the car. Of course, in reality, we can't lift that. It's the jack that does for us because we're no Superman, all right, that can just lift this car. So that's why we're glad that we have a jack. So the total work performed by the jack on the car is about equal to force times distance. So force is 1,000 times 1.25 gives you 1,250 foot-pounds. Now if you want to apply this, or rather convert it in metric unit, then 1,000 is equivalent to 4,448 newtons through a distance of, okay, so 1.25 feet is equivalent to 0.381 meter of a meter. So the work done by the jack would be force times distance, like here, it's just in a different unit of measure, and it's approximately equal to 1695 joules. Now the term joule is named after the English physicist James Prescott Joule. So 1 joule is equal to 1 Newton meter. And it's usually we just denoted by a J. So see how much work done by the jack, which saves us a lot of trouble because in general we only apply about 30 pounds on the jack to get the car moved up. So we're glad that car jack has been invented. Now suppose that the force that you apply on an object changes as it is being moved through a distance along the horizontal axis. So now what happens when a work is done by a variable force along a line? So previously we said that W is equal to force times distance. That's the distance of displacement, and force is constant. So if it changes, that means, let's say for every segment short distance equal to delta x sub k, a force is applied at the midpoint of, x sub k to x sub k plus 1, then each delta x sub k would have a unit work. If you think about it that way, it's like a unit work for every delta x sub k. So now let's add up all that, then that would approximate the work done by a variable force applied on an object. And so, like we do all the time with integration, if we take the limit of this sum and let n approach infinity, then we approach an integral. So this is where integration comes in. So the work done by a variable force along a straight line is equal to the integral from a to b f of x dx. So instead of just a constant f, we have f of x as a function in terms of x.